Hello. This is going to be a fun conversation around how to achieve zero trust data protection in the cloud. This is basically taking zero trust principles and saying we need to center on data protection first and then integrate into the rest of the architecture and how to think about changing your tactics to this new world, right? So the strategy can stay the same. It's centered on protecting data, but our tactics need to change. And Dustin and I will share kind of this journey that we both are going on and we have gone on. We've talked to many CIOs and CISOs about and trying to help you with this kind of transformational change, but making it incremental for you. So to introduce ourselves, first, I'm Jason Clark. I'm the Chief Strategy Officer and Chief Security Officer at Netskope. Kind of been here for 3.5 years. Before that, many times CISO of many, global 2000 companies, and been to security since I was 17 years old when I joined the U.S. Army. To you, Dustin.
All right. Thank you, Jason, and thanks for joining me this morning. I'm Dustin Wilcox. It's always a pleasure to speak about these topics. I am the Chief Information Security Officer for Anthem Corporation. And like Jason, this isn't my first rodeo. Been through a number of Fortune 50 and Fortune 500 companies through multiple verticals talking about these same kind of things and dealing with these same sort of problems. Pleasure to be here.
So what we're here to talk about today is this explosion of data, right? We've gone from 7 zettabytes in 2010 to 57 zettabytes in 2020 to 175 zettabytes in 2025. Just think about that massive growth. Over the next, 4 or 5 years, right, we're going to see a 3 to 4x explosion of data. And the issue is that this is what security is to protect. This is what drives our business, right? And we weren't really built, and our security programs historically have not necessarily been grounded and centered on knowing our data everywhere it is, the flow of our data. And now the issue is the data has really kind of become the first main attack surface that's growing.
Yeah,
But
very
it's
good.
growing. Right,
And
Dustin?
Jason, the way I've heard it described is something like 90% of all known data in the world has been created within the last 4 years. And that to me is a pretty extraordinary factor when we start to think about it. So we're talking about data as an attack surface, but really, I think before we do that, we need to understand both attack surfaces and control surfaces, right? So when we talk about it, they're two sides of the same exact coin. When we think about the control surfaces on premise, the environments we've had to protect for the last 30 years, those really haven't changed dramatically in known history, right? We've had the perimeter to put controls on, we've had infrastructure to put controls on, we've had endpoints to put controls on, and so on. One of the big things that's changing as we evolve into the cloud is that we're going to a space where there's different control surfaces. So different places we can put those controls. And they really come down to three things natively. In the cloud, we have the identity we can control, we have the data we can control, and we have the applications that we can control. And the important thing about that is we still have the same control needs. So what that means is we have to refactor many of the controls we used to have on premise to these new control surfaces.
You think about, how many logins that each of you have, right? Personally, for work, right? All that combined, and how many you're probably adding on a weekly basis, right? I was trying to find the count of number of IDs in the world, and I got a lot of conflicting data. But we know that it is also growing astronomically. So we have the data growing. We have cloud apps that are growing at a 30% pace, right? SaaS apps. Now, most global 2000s have over 2,000 SaaS apps. Half of those are freemium things that your users are just going and using without asking permission from IT, right? And most aren't managed by IT. IT manages 2% of those cloud apps. You've got the identities explosion, data, and then all at the same time, that data is sitting on the mobile devices, right? So it's either in the cloud or on mobile devices, which again is not on a device, right? Or most importantly, it's no longer on a CPU that you own or control. That is this complete flip or inversion of security. Our data is no longer on a CPU that we own, right? That's kind of baffling for the fact that if you look at your spend, 90% of security spend today is still an on-prem, everything's on my network, everything's on devices I own, everything's sitting in my data center world, right?
Yeah, and for me, the analogy that I like in the new world too is really the old pen test analogy, where it used to be for me every time we'd have a new pen test, there would always be this one particular finding that showed up every time, year after year, and that finding would be the result of some hardworking, young system engineer having set up a new SQL server the night before, and hadn't hardened it yet to our guidelines. Because of it, it showed up on the pen test as having, default credentials or a vulnerable stored procedure or something like that. Now take that and apply it to the cloud reality we live in today, where people can go out, end users can go out on a purchasing card and buy a new SaaS service, or as you said, a freemium service, just decide to start using it. And all of a sudden those things showing up, how do we detect those things? That's such a part of the attack surface, because then we have APIs exchanging data, and all of those, all the problems that come along with that, our inability with the old legacy controls to inspect the APIs and so on. So you get start to get the idea of just how much this attack surface is not only, multiplying, but how hard it is to see within that attack surface. So now we get back to the question of strategy versus tactics. So we're really here to talk about how the tactics are changing, going from premise to cloud. But before we do that, let's talk about the other side of the coin, which is the strategy. The strategy doesn't change at all. And here's one of the things I always try to emphasize for people is the winning security strategy is, it's well known, it's well understood, it's universal, and it hasn't changed for the last 30 years. Do three things ubiquitously well and you win at information security. You minimize the attack surface. That's strategy pillar number one. You complicate unauthorized access. That's strategy pillar number two. You rapidly detect, respond to, and contain incidents or threats. That's strategy pillar number three. It's 14 words to describe everything we have to do right as an information security program. It's the easy part of what we do. The hard part, candidly, are the tactics. The tactics, those change not just one company to the next, one industry to the next, but really 1 year to the next, or 1 day to the next, depending on what kind of threats are attacking us, right? And that's where cloud is definitively different than premise, because the control surfaces are different. The tactics have to be different. The tools, tactics, and processes we use have to be very much different.
I just want to reiterate this point, Dustin, because it's so critical, right? Our strategy is not changing. It should not change. It's always been the same. Is to do these three things that Dustin just talked about. However, what I do see and consistently is people say protecting data is hard, so they don't have the classification strategy. They buy technologies and they're chasing threat, right? Or they're chasing various things and they're trying to calculate risk without understanding the value of their data. So protect data is grand strategy, right? The next level of the strategy are these three things: reduce attack surface, complicate unauthorized access, and rapidly detect, stop threats. The tactics are what's changing, right? The fact that the data is no longer in our data center, or it's no longer on our network or a mobile device we own. We have to change our technologies, our processes, our people, the partners we engage in, et cetera. That's this massive change. And it doesn't have to be massive. It can be incremental. And that's what we want to help you with.
Yeah, and Jason, a really good example here of a tactic that's changing is a firewall, right? In that legacy environment, we had a firewall that sat at the edge of our corporate network between us and the internet, and that was a tactic we used to both complicate unauthorized access and to shrink the attack surface, right? We use it for both of those purposes. Well, in a native cloud world that we're moving to, there is no firewall. But we still need those same capabilities, those same control capabilities the firewall gave us. So we have to refactor those into those control surfaces. The three we talked about: the identity, the application, and the data in the cloud. That's really important. And here's a really good visual representation of how the paradigm has changed. So in that legacy world where we had those legacy controls sitting at the edge, it was really very serial, right? Packets would come into our network. They would pass through an IPS. They would pass through a firewall. They'd pass through probably a DLP appliance of some sort. There was a number of stage gates they had to pass through, but they were pretty much serial as it happened. So they happened one at a time, and each of those controls happened in context only to itself. And what's really changing here is we now have an opportunity to apply controls in parallel. And for me, it's really the definition of secure by design. That legacy world, we were layering on controls, retrofitting them into legacy technologies that frankly were built initially without security in mind. Now we're having the capability, as we build new controls, we're having the ability to do so in a way that is secure by design. What that means is parallel processing. And what parallel processing gives us is all those controls can be applied at the same time in context to one another. So they can all learn from one another and apply that context to whatever control decision they're making. That to me is critical.
This is a perfect example of why we need to evolve. It's not just that our data is in a different location. It's the power of cloud to protect our data, right? Historically, what we did is we stacked tech after tech after tech after tech, and each of them were a bump in the wire that did their own serial processing, and then it would say move on to the next thing: IPS, secure web gateway, right? Firewall, et cetera, right? DLP inspection, email inspection, sandboxing. But all of those were individual things that weren't all connected as one system versus all of them firing off atomically, right? Imagine the packet going in instead of serial processing. You say, tell everything to inspect this thing, give me the answer back. Now that it allows me to have the data gathered at the same time, but also be able to do it faster. This is game changing, and it's only possible in cloud, right? You don't
Yeah,
have enough. Right?
yeah, and Jason, some of us look at this at the prospect of having to refactor all these controls as being a daunting prospect, right? An intimidating prospect, trying to figure out how we're going to retrofit these things the best way into new control surfaces. I will tell you what, though, you know me, I'm a glass half full kind of person, and I am so excited about the opportunity it represents because for every one of us, everybody listening to this, everybody that participates in the white hat side of information security, this is probably the only opportunity, certainly the best opportunity we'll ever have through the arcs of our careers to do this secure by design, to get this right from the beginning and finally level out what has been traditionally an asymmetric battlefield.
Yep, I've heard. There's a friend of mine that says this is the perfect reset opportunity for security, right? And I'll give an analogy around what this of the why, right? And an analogy of way to think about this. I think about it like the way our body protects itself, right? Versus necessarily let's moving away from networks for a second. We have our nervous system and we have a brain, right? And I'm gonna start with the nervous system. So this is the simplest way to describe SASE. It is all of your senses. It is the things that we bought separately and put in that serial processing to focus on one action: protect web, protect cloud, protect all ports, all protocol, protect ingress, egress, do user behavior stuff, do VPN, etc. All of a sudden, it's like to me, it's like senses of smell, hearing, taste, seeing, all together. Say I smell that there's a fire, or I hear there's a fire, but I can't see it. I don't know exactly what to do, right? Do I run? Do I call 911? Do I grab the extinguisher? What do I do, right? And for that, I need all the senses firing off on the one nervous system versus, honestly, simply put, what we've done for the last 25 years, right? All of us have. We've essentially Frankenstein put technologies together, right? Even if we buy one brand, right? Some of the big brands out there, we really like a Cisco as an example. We just Frankenstein they're just acquiring companies and then saying, hey, we have it all, right? Versus truly building things into the nervous system from the ground up.
Yeah, and again, here though is where all the controls taken in context to one another is really important. And this is a good diagram to show it. And you use the example of fire. Our central nervous system, we can see the fire, we can smell the smoke, we can feel the heat, right? We can probably even taste the soot if you think about it in a fire. All those things together tell us not to pick that thing up, right? All those things in context to one another tell us that burning thing we shouldn't touch. And the same is exactly true with information security. If we can take all those control inputs, take them in context to one another, suddenly the sum is greater than the whole, right? The sum is greater than the parts of the whole. And that for me is really important here because, again, you could lead to different decisions. Think about something on fire. If it was just a picture of something on fire, you could reach out to it and touch it. If you only have the eye that's giving you the input, you would not want to pick that thing up. But if you have all your other senses telling you that it's not hot, it's not smoking, right? Now all of a sudden you can make a better, more informed, correct decision that tells you it's just a picture of fire, it's not actual fire, right? The same is exactly true for how we control things. We want that full context because otherwise we might have a false positive, or in worst case scenario, we might have a false negative.
So I know we're saying SASE. Just for anybody that's not familiar with it, it is Secure Access Services Edge. This is one of the best papers I've ever seen being published by Gardner. It is a discussion in almost every single company I go to now about developing a SASE strategy, which is really taking all of your traditional network and data and cloud security technologies and converging them into one, right? For all the benefits that we just talked about. Now, the second part of that, though, is extremely important. It is connecting the brain to that nervous system. It is what do we do with that information? All now that we actually are centralizing this information versus historically, each of those things acted instinctually using, let's say, ACL. So things were binary, on, off, right? Now all of a sudden, I'm adding things at the same time that can say, how risky is that app? Not just does my URL filter say the app is compromised or not? But is it a safe app? Meaning, how many security people do they have? What's their SOC 2? Where are they hosted? Right? What type of data do I have there? Is it my own instance, a managed instance, or a private personal instance of G Suite? What's the user behavior? How is that changing? Tell me about the identity, right? Now tell me about the threat aspects on the device or in the network, right? What does threat intel tell me from a dark web perspective? All of these things. And then all that correlates to what's the data context, right? How important is the data that I'm protecting? Because if somebody's uploading something that is not even owned by our company to a site that, let's say, is not compromised, but I don't think is safe, is there a risk? Not really. It's something that was already public, right? But if it's something that is sensitive to me, then I care and I want to act, right? So it's this leveling, and by adding more and more and more context, like context is king, is kind of what people in security are saying now, right? The more context I can have. The issue has been we might get a whole bunch of context, but we're dumping it into a SIM, which is more like a memory. So then analysts have to go after the fact and look at the stuff, right? Versus being able to live, real time, make risk-based conditional access control decisions on everything the user's doing, the app's doing, the network's doing, the device is doing, etc. And this has never been done before.
Yeah, Jason, the way I would like the practitioners watching this to think about SASE, at least from my perspective, is it becomes a fourth control surface that we can apply controls to. We talked before about the native controls surfaces being identity, application, and data. SASE becomes a fourth one where we can provide and apply controls in parallel to one another and in context to one another, fully integrated.
I like that, Dustin. I like that. I think it's a great, great message. How do we bring this to zero trust? Well, SASE is about bringing all the senses in, bringing the data in. What zero trust is, then the decisions we make around that, right? So understanding, okay, I'm getting the senses of what's the likelihood of the risk, what's the impact of the risk, right? How important is that data? I understand that my data risk, and I say, what's the trust level now? What trust level do I give that user or that device or that app to this piece of data, right? And it's not on off. It's a binary. It's not a binary conversation. It is more like this. It's a continuous risk conversation.
Yeah, very good. And here would probably be a good point for us, Jason, to sort of center on a common definition of what is zero trust. You know how this goes. We've had a lot of these conversations, and if you get 100 security professionals in a room and ask them what zero trust is, you're going to get 100 different variations of the answer. And for me, it's become such a buzz term in our industry. I like to try to boil it down to what it really means. And I guess in my mind, it doesn't really mean quite zero trust. It means very simply, let's not trust the things we don't have to trust and shouldn't have to trust. Real good example there are networks. We don't control networks anymore. We for years have assumed the network was breached. Let's not trust the network. But there are some things we do have to trust. And for those things, let's use the old security adage of trust but verify, and let's constantly verify. So ultimately, we have to trust the identity that we've provisioned to an individual, but let's constantly verify that identity, and let's verify it based on a number of risk principles, things like geographic location. Is it coming from a device that I've seen before? Is it behaving appropriately according to whatever the typical behavior is? Those types of things. So trust but constantly verify. That to me is the essence of zero trust.
Yeah, Dustin, I think most organizations, most IT executives, security executives I talk to, they say their teams are confused about zero trust. To your point, there's been so much marketing around it that people are like, look, we have these isolation, right? These workload isolation projects. We have our identity projects with Okta. We have our network, right? And we have our endpoint that's doing it. And so everybody's a little bit confused around it. It's like, guys, no, it's all. There isn't one zero trust solution. It is an architecture. It is bringing it all together, right? Bringing and those components, they have to be automated and integrated and orchestrated together. But it's all around access to data, right? So you have to understand your data first, and then bring all those players and making sure that they work together, right? If one of your providers in this architecture isn't being friendly with another provider, then you need to rethink the architecture or put a lot of pressure on them, because otherwise you can't be successful. And another part of this, success is that this is not, hey, I'm just going to be zero trust overnight, right? This is absolutely an incremental change. And I show this dashboard here because you can't go from, all right, I'm going to go to digital, right? You're going to start with analog. You're going to add some digital components, but you're still going to be relying on your analog components, right? Over time, you can be completely digital, right? But it is still a journey. Some people, it's a 1 year. Some people, it's a 7-10 year journey. It just really depends. Dustin, in a talk he and I did in the past, he kind of said, look, it's enable the future and protect the old, right? That's our job. And we have to do both, and we have to do both well.
Yeah, not only that, I think we have to, we really have to put pressure on our vendors, our strategic partners to help us do that. I've seen a lot over the years, a lot of really great new innovative capabilities that completely ignore the fact that I do have that legacy I still have to protect. So as we're talking about zero trust, the first thing I note is that, as you said, it's a migration. It's something that happens gradually. We work our way there. But let's understand we're not there until we've built zero trust through the entire sort of access pipeline between the individual, the application, and the data. It all has to be zero trust for us to get there. But there also needs to be that integration layer, because we are going to have, some of us, legacy technologies that will never be zero trust. We'll have to migrate those to new technology before we can get there. Here I'm thinking about some of these mainframe systems that have been around for 30 years that we're all, a lot of our industries have to continue integrating with. There, we're going to have to pressure those strategic partners who are building us these innovative new tools to do so in a way that gives us an integration layer to the legacy.
The reason I'm showing this, this digital dashboard and this plane and this Cessna is because of the fact that you think about everything this has replaced. Think about the physical map, right? The having zeroing on the radio communications. I mean, every aspect, all the instrumentation, and the instant decisions I can make, right? The immediate, important decisions I can make, and how much faster I can make that. That is what happens whenever you take that first couple of steps in the SASE and zero trust journey. Is you will see this. It literally reduces friction, right? Optimizes friction and reduces risk at the same time, right? And we'll talk about that because of how fast you can make decisions with all the additional context that you have. To give an example of that, today many organizations are kind of in a things are not allowed or not, right? You can go to that website or you can't, right? There's not a lot of in between. You can upload data or you can't, right? It's an on-off. It is a very binary. I trust or I don't, right? But we have to open this up now to optimize this friction, to be able to enable the business in the best way, to be able to manage the risk in the best way, and to add additional context, right? So it first starts, imagine these dials that you're doing here, right, with your SASE solution and zero trust solution is, okay, what's the activity I want to perform? I want to do an upload. Great, the dial's on upload. Now it's going to a site that has a poor risk rating, right? Like Netskope has a CCI risk rating, which is Cloud Confidence Index. So it's saying this website, it's not hacked, but we know they're not good at security, and you want to do an upload. Well, the risk is high. Notice the risk to the right. But, it's an authorized user, right? And it is data that is public. So the risk comes down because I'm uploading to something that isn't hacked, but I know that they're not good at security, but it is public information. So do I care? I care a little bit, right? But not that much. So what am I going to do? I'm going to coach the user. I'm going to engage the user and say, hey, a pop-up might come up and say, can you type the one sentence business justification of why you want to upload to this site that we deem as risky? The person can back out. By the way, I see 98% of people generally back out when confronted. We're not saying no. We're just saying, can you just tell me why? Like, we just want to understand. What we're really doing is kind of doing just-in-time training to them to let them know that this place has some risk, right? And they need to be aware of what they're doing, right? But now let's change the scenario and say that it's confidential data. They're actually trying to upload confidence. So let's say they typed the one sentence and they said, yep, I'm researching this new SaaS app, and they hit enter. We let them go. They upload public information. But then they go to upload PII, right? Let's say it's your HR team uploading HR information. All of a sudden, right, you're gonna say, well, I'm gonna block that, right? And now, but you can do this, you can upload that information to this managed instance, to our managed CRM or to our managed HR system, right? So based on these various scenarios, right, it's not on off, right? The risk level comes up and down, and you're engaging the user to make these various decisions. You can do, working with Okta, we can do step-up authentication, right? Based off of how the risks change. Hey, you authenticated 5 hours ago, but now you're trying to upload confidential information. I'm going to make you re-authenticate. right? Because you're trying to do something I've not seen you do or that has some risk to it. So now maybe you're coaching them, but you're also making them do step up authentication, right? And so you understand you can continue to play with these dials with unmanaged devices versus managed devices and all the things that you can do versus allow block. But in the end, right, the issue is you want these extra dials. That is what SASE and a zero trust data protection focus gives you. These are the things that 95% of security teams do not have today. They're doing these individually, but not all integrated and not in real time, right? This is a major evolution for security, and everybody should kind of be thinking about it in this way.
Yeah, and you can tie it back to the whole conversation around the legacy concept of applying controls serially and the go forward concept of applying them all in parallel. Had we applied these controls serially, the first one was, is this a good website or a bad website? The answer would have been, it looks pretty bad, and we would never gone on to the other questions. We would have dropped the traffic right there and then and there. Now we can ask and answer all those questions in context, finding out that there is maybe a valid reason to do this, finding out that the relative risk to the data is pretty low because it's not critical data. Now all of a sudden we can get to yes, and we can empower our end users, our customers, to make the right decision for the business. So you talked a little bit, Jason, about optimizing friction, and I love that you're careful to use that term optimize and not minimize friction, because really when I look at what a good security project looks like, it does three things. The first thing is it reduces cost, and sometimes that's the cost related to risk, right? So we have to quantify it that way sometimes. But the best security products do all three of these things. They reduce costs, they reduce risk, and they optimize friction. And here that term optimize is really important. Some people will say, why don't you say minimize friction? And that's because, quite frankly, as CISOs, there are certain things we do, and we do on purpose, that increase the friction. They increase the cost of people doing bad things, right? We want certain things to be friction so people won't do them, and we encourage them to use a less friction process. So that's why we use the term optimize friction. For my own practice, I will tell you that I don't do any project unless it can check at least two of these boxes, right? And I get really excited about any project that can check all three of these boxes. In my mind, the best security projects check all three.
That's an awesome way to think about it, Dustin. Right? At each check two, check three. Wow, this is a great project. The optimized friction. Think about it in that pop up where you're not telling the user no. You're just saying, can you type one sentence why? What you're doing is you're just engaging them. You are creating a friction point, right? But you're not saying you're optimizing it based on their response. And that's I think that is the key to really a very successful business aligned security organization. So how does this work in practice, right? So one, we're talking kind of like think users are trying to get to apps. They're trying to get to apps because of data. Some of those users are internal. Some of those apps are internal. But more and more, it's users off the network, and it's apps that are off the network, and they're on CPUs that you do not own. And today, a lot of your security is to the right, right? A lot of the security is internal, and you're trying to kind of bring everybody back. What you're doing is you're bringing them back into internal, maybe VPN backhaul, to then go to an app, right? Or you're saying, you know what? I'm just letting them go direct. I just can't backhaul. I'm getting too much pressure. I want to let go. I want to minimize friction so they can go direct versus optimize friction, as Dustin just pointed out.
Yeah, and Jason, this is the this is the view for me that accurately, visualizes what legacy security approaches look like. This is what it looks like to have to retrofit security controls serially into legacy technologies that weren't built with security in mind. I've described this before as this view as the spaghetti monster that we end up with as we try to do that. You would expect that a control approach that was secure by design, if you'd have visualized that the same way, it would be much more symmetrical and elegant.
I look at this like what we've done is we've added, remember that Frankenstein comment I made? What we're doing is we're adding tech after tech after tech, reacting. And that's what we've been doing. We've been reacting to use cases. It's like there's a leak in the dam of water and we're just putting our finger in, right? But it's now we've got 30 fingers in the dam and we're just trying to hold that thing versus, all right, as Dustin kind of said, very important, security by design, right? How do we rationalize this? What do we do, right? And first, you start and say, this needs a center on data. That's what we're trying to access. That's what's sitting in the cloud. That's what's sitting on these mobile devices. That is what the grand strategy of the main thing we're protecting, right? And so we have to simplify it and say, we want to secure it and we want to access it. And what are the requirements of that, right? You work with the app teams, right, with the business, with the network team, and talk about how you get you know 5 nines and how you make it a fast user experience, how you have resilience, right, built in all the way through. But then you have the deep conversations on how do we get better in security? How have we gone backwards as data has not been on a network or device or CPU we own, right? And how do we get that security controls back? In fact, not just how do we get it back, how can we even make it better? Because the cloud does enable that, right? And so as we rationalize this, how do we simplify the spaghetti monster? It is, or what's the answer? And one thing that is, I've been recommending a lot, and I've seen a significant portion of the Global 2000 kind of adopt, is saying this SASE zero trust transformation, a big, massive foundational step is a next-gen secure web gateway. That is the way that I can get visibility of all my users to all the apps, wherever they are, anywhere, everywhere, right? And I can get, and this has to be in the cloud, right? And it has to have a CASB component. What a next-gen secure web gateway is it's a CASB combined with a secure web gateway, combined with a DLP, so that you can understand the context of everything happening in those SaaS apps. What's the user doing? What's the activity? How safe is that app? Combined with all the traditional stuff our proxy did, threat inspection, URL inspection, right? Combined with, I need to understand the data because that's what I'm protecting. And then I can do the risk-based calculations that we talked about, right? And the trust level discussions. And then I add use cases. I say, well, now I have 20 users that I'm a little bit worried because they're scientists and they have access to some intellectual property. Maybe they're inventing the next vaccine, and I want to do user behavior on them, right? On those specific users. Or I have a salesperson who is 99% of all their apps they access are SaaS apps, but they have this one app that's sitting in the back end of a data center, or they're a developer and they're a consultant, and I need to get them into the back end of my data center or into AWS, but that's not front ended by a website. And so I need to add private access. I add a VPN solution, right? Remember whenever Dustin talked about parallel processing, this is atomic. This packet goes in, we've already done the hard work. And then all the decisions get made at the same time. It's think about this. Before, it's like you bought a phone, and then you bought a flashlight, you bought a GPS, you bought a calculator, right? And you taped them all together and said, this is one device, or you had them all in your briefcase, right? Versus now, it's just apps. Those are just apps running on the iOS. That's kind of what we want to do in this parallel processing world, in this cloud world, is saying everything's just an app. I don't have to hire 300 developers to build the new app. I actually just have to hire a few and have them add the app or the module into this existing SASE architecture, right? And so you just add on to this. And what's SASE? Well, then we take that same threat inspection, DLP inspection, user behavior, right? Integration and identity, and we add it for all protocol, firewall as a service for egress, right? Or we integrate all SD-WANs, or we do browser isolation, right? Or we do DNS security. All of this is just a user going to an app, and I'm just adding inspections versus adding boxes in the line. I'm just adding inspection in that same cloud inspection point, and they all fire off at the same time, which then enables us to move from this binary allow block to give me all the additional context of the app, of the identity, of the location, of the website, and most importantly, of the data to drive what level access do you get. Is it 0? Is it level 5, meaning all access, I fully trust you? Or maybe it's something in the middle, right? Like whenever we were moving the dials, maybe it's I coach you. I say, wait, can you type the one sentence? Or maybe it's, no, you know what? You're on your iPad. I'm going to give you view edit only, not full access. So all of this is SASE and zero trust combined, right? You're making zero trust decisions, risk-based conditional access decisions in a SASE model, right? To drive reduce risk, reduce costs, and optimize the friction.
Yeah, and Jason, it shouldn't be lost on anybody as they contrast your atomic diagram here to the spaghetti monster diagram we saw before, that this is what visualizes secure by design. This is the symmetry I was talking about in secure by design. And with that, we get all controls applied in parallel. and all control benefit from the context from every other control.
Yep, exactly. Right. I've shown this. I showed the spaghetti slide and then this slide to a CIO who stood up and looked at his team and said, "This is like Prozac for me. There's like this just calms my nerves because I'm very very worried about all the stuff we have and all the exposure we have. And if we were on something like this, I would sleep better at
Yeah, well, your
night."
CIO, your CTO, and your finance partner will all probably look at the spaghetti slide the same way and understand that it
Yeah.
represents complexity, and with complexity comes cost, not to mention risk that comes with complexity. So removing as much complexity as we can, I think, is one of the goals that we all share.
Yep. Complexity is the enemy of security, right? So
Indeed.
simplicity is our friend. And uh, and so when you think about, well, how does this work? What does this architecture look like? It is, it's what you used to think of network security. SASE is basically replacing network security, but moving that out of, being entombed in a box sitting in your data center or 100 boxes sitting in your data center to moving it to the cloud and giving it cloud and data inspection at the same time as network inspection while fully integrating, right? With your identity players, right? Okta, with your endpoint players like CrowdStrike, and your SIM orchestration players, right? Like Splunk and Sumos of the world. Right? This is a very simplified architecture for egress zero trust, right? I'm not getting to workload isolation or anything like that. I'm just saying that from an egress standpoint, when we think user to app, right? This is kind of the simplified architecture. And the most important thing here is you need them all to be working together. They have to be integrated. They have to be working on features together. They have to have open APIs. You have to be able to code against them. And again, the SIM is there as a memory. It's good for your red teams. It's good for threat hunting. It's good for a lot of things, compliance. But in real time, at the endpoint or in the network or in the app, you've got to make real time decisions and you cannot wait or rely on the SIM to do that. So, in closing, this journey, this is an example journey. This is a common one I see with many, many organizations. And it is one realizing I'm a data center centric security program. And the first step, the foundational step for me is next gen secure web gateway, right? To get that new visibility of where I'm exposed today because I can't see the apps or the users off my network and I don't want to backhaul them. Integrate, right? And most importantly, integrate to the SSO MFA, right? Integrate to Okta, right? That those things together is moves the risk reduction, right? And the optimized friction needles heavily. Then after that, you start to work on making it intelligent. You build your DLP rules. You use ML AI to build behavior rules around and understand and build models around your own data, around your own users. And then you then progress and say, now I'm going to go zero trust. Now that I have that information about my important data and the risks of my users and the risk of my apps, now I'm going to make zero trust decisions, right? That's 0 to 5. And I'm going to kind of untether myself from my legacy VPN, right? I'm going to kind of go full blown SASE and zero trust. That is a common journey that I've seen many, many organizations plan and execute in a very successful way. So with that, Dustin and I, love sharing what we're seeing in the world and how we can help organizations. Both of us are very open to engaging or helping anybody in the community, whoever it is, on this journey and giving advice, giving tips. We will be around for questions in the chat room, and look forward to hearing from you all.
Yeah, thank you, Jason. Thank you for joining me today and letting me join you. Thank you for the conversation. I look forward to the questions. I always do, particularly if anybody wants to challenge the premise that security strategy is easy and try to find something we do that doesn't fit in neatly into those three pillars: minimize the attack surface, complicate unauthorized access, rapidly detect, respond to, and contain incidents. It's all in there.